Okay, so quadrilaterals part 2. The video stopped, and rather than starting over, I'm just going to pick up where I left off. So we were at rectangles, okay? Rectangles, you know what a rectangle looks like. It has 2 short sides and 2 long sides, all right? Now, I didn't erase the 2 sets of congruent and parallel sides because that is true of a rectangle as well. A rectangle is technically a parallelogram as well because it has 2 sets of sides that are parallel and it has 2 sets of sides that are congruent, okay? What makes a rectangle different or even makes it a special kind of parallelogram is that it has 4 right angles, okay? So next to the A, you're going to write 4 right angles. And I want you to write in this box that a rectangle is a parallelogram, okay? The only thing that makes it different than the parallelogram where it looks like the rectangle has been pulled, right, is that this one has 4 right angles, okay? And you know that about a rectangle already, all right? So now, here's the deal. Moving on to the next box, we're gonna drop right below the rectangle to the square. And everybody's gonna draw a picture of a square. We're gonna write square at the top of our box. Here's my square, right? Oops, it's a square. And what do we know about a square? Well, it does have, I have to erase this now. I have to erase the sides on mine. And you are going to write what about a square? What do you know about the sides? Think for a minute. Oh yeah, all the sides are congruent. So for sides, we have all sides congruent. We still have 2 sets of parallel sides. I don't have to erase the 4 right angles because it has 4 right angles, and it is also a parallelogram. It's a special kind of parallelogram because all the sides are congruent, okay? So that is a square. Everybody good? Excellent. Okay, so now we come to rhombus. Now, I'm going to erase the angles on this one, but I'm going to leave the sides, and you're going to copy the sides for this, okay? A rhombus is also still a parallelogram. A rhombus can look 2 different ways. Okay? This is a rhombus. All the sides are congruent, okay? And in this case, all the angles are congruent, and they are all right angles. This, my friends, as you can see, looks just like a square that's been tilted, okay? A rhombus can be a square, okay? But not all rhombuses are squares because it can look like a stretched out parallelogram where this is an obtuse angle and this is an obtuse angle. This can be an acute angle and an acute angle, but all my sides are congruent. Okay, so a rhombus can be a square, but not all squares are rhombuses. Okay, or not all rhombuses are squares. I'm sorry. A square is always a rhombus, okay, because it is technically a parallelogram where all the sides and all the angles are equal. But this would be an example of a rhombus because all the sides are congruent. It is a parallelogram, but it has obtuse and acute angles. So not all rhombuses are squares. All squares are rhombuses. Not all rhombuses are squares. okay? The last quadrilateral that we're going to talk about is the trapezoid. That's what's at the bottom of your page. So I'm going to erase all of it because trapezoids are special. They are their own little monster. Trapezoid is special, okay? Now, when you learn trapezoid, if you've ever heard trapezoid before, first of all, I'm going to tell you a trapezoid is not a parallelogram. Not a parallelogram. Because I'm going to draw the two trapezoids that you generally see. This one, okay? And then it can also look like this, okay? This one has a right angle. This one has no right angles. It has two obtuse and two acute angles, okay? And this one actually has two right angles, an obtuse angle, and an acute angle, okay? Both of those are examples of trapezoids. They are four-sided figures. That's what makes it a quadrilateral. But there's a difference that disqualifies it from being a parallelogram. Can you see what it is? Do you have any idea? Parallelograms had to have two sets of parallel sides, right? Okay, well, if you look here, this side here and this side here, those run parallel. If you continue them on and on forever in the same, forever and ever and ever, they would never ever cross. That makes them parallel. They stay the same distance apart. Same is true on this picture here and here. Those two sides, if you ran them on forever and ever, they would never ever cross, okay? They would be parallel. However, this line here that makes up this side, and this line here that makes up this side, if we continued them on, eventually they would cross, okay? So those sides aren't parallel. Same thing here and here. If I continue this on forever and ever, and this forever and ever, eventually they would cross, okay? So what makes a trapezoid not a parallelogram? It only has one set of parallel sides, okay? For angles, it has a variety of angles. Sometimes it can have right angles, okay, like in this one. Other times it doesn't have to, okay? So for angles, it can have right angles. Or it can have a combination of obtuse and acute angles, okay? Combo, obtuse, and acute, okay? So that's the basics of quadrilaterals. Hopefully you watched both videos. I'm going to modify the notes and tell on the website. So hopefully you watched both of these, okay? And if you, for some reason, missed parallelograms, which was in the first video, you need to go back and watch it, all right? So make sure you're at your Zoom meeting so we can talk about this and we can go over the worksheet that is going to be in Shobi, okay? I'll see you in a little bit. Bye.